April 2025. A lawsuit sends shockwaves through the world. A family alleges an AI companion chatbot contributed to their son's tragic end. We live in an era defined by artificial intelligence. It powers our cities, our economies, and increasingly, our most intimate relationships. This tragedy forces us to confront the profound duality of AI, a technology capable of solving our greatest challenges. At Rawino, we share content that inspires, informs, and entertains. Subscribe and join the Rawino family. The AI landscape of 2025 is powerful and pervasive. Models like GPT-5 and Gemini process reality in ways we barely understand. This isn't just a story about technology. It's a story about humanity's oldest ambition, the desire to create intelligence outside of biology. To understand this turning point, we must first understand where the journey of the thinking machine began. The ambition is ancient. Myths like the Golem of Prague explored the dream of inanimate objects brought to life and the dangers of hubris. The Enlightenment shifted the dream from myth to mechanism. Inventors built complex automatons, the first attempts to mimic life through engineering. In the 19th century, Babbage and Lovelace conceived the first programmable computer, realizing that complex reasoning could be mechanized. The 20th century brought the dawn of computation, largely through the vision of Alan Turing. He defined the theoretical model for computation itself. During World War II, Turing turned theory into reality, building the bomb to crack the Enigma code, significantly shortening the war. In 1950, he proposed the imitation game, the Turing test, a pragmatic benchmark for machine intelligence. Turing argued the key wasn't programming an adult mind, but creating a child machine that could learn from experience. In 1956, the field was officially born at the Dartmouth workshop. It was here John McCarthy coined the term artificial intelligence. The golden years followed, marked by optimism and early demonstrations like the Eliza chatbot and Shaky the robot. But this hype crashed against reality. Early AI failed in the real world, unable to handle the combinatorial explosion of complexity. The scathing Lighthill report triggered the first AI winter. Funding dried up and progress stalled. AI re-emerged in the 1980s with expert systems. A commercial boom ignited, but it too collapsed when specialized hardware became obsolete, triggering the second AI winter. Yet, beneath the frost, a different approach was brewing. The backpropagation algorithm offered a way to train deep neural networks effectively. As the second winter thawed, IBM's Deep Blue defeated Garry Kasparov, signaling the rising power of computation over symbolic reasoning. For decades, progress was bottlenecked by a lack of data and power. The internet and GPUs changed everything. The watershed moment came in 2012. AlexNet, a deep neural network, shattered records in the ImageNet competition. The deep learning revolution had begun. This approach rapidly transformed computer vision, speech recognition, and language processing, culminating in the release of ChatGPT in late 2022, bringing the power of generative AI to the mainstream and triggering the current global AI boom. The AI landscape of 2025 is a fiercely competitive arena. Labs navigate a strategic trilemma, balancing capability, openness, and safety. OpenAI's GPT-5 aims for AGI with a unified system architecture, featuring an intelligent router for dynamic reasoning. It boasts state-of-the-art performance in coding and agentic tool use, deeply integrated into Microsoft's ecosystem. Google DeepMind's Gemini 2.5 Pro is engineered as a natively multimodal thinking model. Its standout feature is a massive 1 million token context window, enabling it to analyze vast datasets in a single prompt. Anthropic's Claude 4.1 prioritizes safety and reliability for enterprise applications, excelling in precision coding and complex workflows where accuracy is non-negotiable. Meta's Llama 4 leads the open source movement, using an efficient mixture of experts architecture to democratize access. The Scout model's groundbreaking 10 million token context window unlocks entirely new applications. And xAI's Grok taps into real-time, unfiltered data from X, offering up-to-the-minute information and a provocative personality. But this reliance on unfiltered data makes it highly susceptible to absorbing misinformation and toxic rhetoric. Beyond language, generative vision has exploded. Midjourney 7 leads in artistic quality and photorealism, while models like Stable Diffusion 3 offer open-source power, and OpenAI's Sora generates remarkably coherent video from text. AI is the archetypal dual-use technology. Its benefits and harms are often two sides of the same coin, emerging from the same core dynamic. Scaling. In medicine, AI algorithms diagnose cancers with superhuman accuracy and create personalized treatment plans. In science, AI is a catalyst. AlphaFold solved the grand challenge of protein folding, dramatically accelerating drug discovery. It provides unprecedented accuracy in weather forecasting, critical for managing a changing climate. Economically, AI optimizes supply chains, detects fraud, and drives massive productivity gains across the board. But the rapid deployment of AI introduces systemic risks. Economic disruption is already here, automating cognitive labor. Entry-level roles are vanishing as AI automates the routine tasks typically assigned to junior employees. One of the most insidious harms is algorithmic injustice. Trained on historical data, AI absorbs and amplifies existing human biases at scale. The data-hungry nature of AI creates a powerful incentive for mass surveillance, posing a profound threat to individual privacy. Generative AI threatens informational integrity. Deepfakes can disseminate misinformation at unprecedented scale, eroding the factual basis of democracy. The environmental cost is staggering. AI data centers are voracious consumers of electricity, contributing significantly to emissions. They also require enormous amounts of fresh water for cooling, straining resources in already water-scarce regions. Furthermore, the specialized hardware contributes to a growing stream of electronic waste and relies on intensive mineral extraction. The public image of AI is one of sleek innovation, but behind the silicon curtain lies a messier, ethically fraught reality. The quest for autonomous intelligence is paradoxically dependent on hidden human labor. The ghost work of data annotation is crucial for AI safety. Investigations revealed workers in Kenya paid less than $2 per hour to view traumatizing content to build safety filters for ChatGPT. The industry is embroiled in legal battles over data scraping. The foundation of modern AI is built on appropriated human culture without consent. Lawsuits from media organizations and artists challenge the legality of this approach, threatening the industry's business model. Controversies over the misuse of likeness and voice highlight the emerging ethical challenges of AI mimicry. The immense pressure of the AGI race creates volatile environments, leading to public power struggles and deep ideological schisms within the labs. And the deliberate choice by some labs, like xAI, to train on unfiltered data leads models to echo extremist viewpoints, revealing profound ethical risks. The profound risks have spurred a global race for governance, leading to two distinct and competing philosophical approaches. The European Union has taken the lead with its comprehensive AI Act, a risk-based framework prioritizing the protection of fundamental rights. It bans practices like social scoring and imposes strict requirements on high-risk applications in employment and justice. This Brussels effect is poised to set a global standard, compelling international compliance. In contrast, The United States pursues a market-driven strategy, prioritizing innovation through executive orders and sector-specific guidance. U.S. regulation is often politically inflected, as seen in the controversial 2025 executive order targeting woke AIs in federal procurement. This fundamental clash of values is creating a global regulatory schism that will define the future of AI development. The field stands at a critical juncture. The current paradigm of simply scaling up models may be approaching a plateau of diminishing returns. Persistent problems like hallucination suggest scale alone isn't enough. The next breakthroughs may require novel, more efficient architectures. The next decade will see the rise of Agentic AI, a shift from passive models to proactive systems capable of executing complex real-world tasks. An economic reckoning is coming. The industry must prove that productivity gains justify the colossal financial and environmental costs, or risk another AI winter. The ultimate goal remains artificial general intelligence, a machine with the full breadth and depth of human cognition. But today's systems are still sophisticated mimics. They lack genuine understanding, consciousness, and the ability to reason from first principles. The path forward is fraught with challenges that are not just technical, but deeply ethical and philosophical. The history of AI is a story of ambition and repeated lessons in humility. Technological progress is not synonymous with human progress. The single most important task of the 21st century is not simply to build more powerful AI, but to cultivate the collective wisdom to steward it responsibly. The ultimate success of the AI project will be measured not by the intelligence we create in our machines, but by the humanity we preserve and enhance in ourselves. Thanks for watching Rawino. Your support means the world. Enjoyed it? Like and subscribe for more.